Good evening, ladies and gentlemen. Would you like to play a game teaching a computer to see a chessboard? Who am I? My name is Mitch Kane. I have a BS in Applied Mathematics from the University of Rochester, and I've spent the last 13 weeks in the Galvanized Data Science Immersive program. And I recently left the Marine Corps after 5 years. Why this project? Well, I love chess, but I'm not really very good at it. I'm okay on my cell phone, but my over-the-board game is horrible. And I figured I could use machine learning and computer vision to make a tool to help me practice. It's a very interesting area to work in, and I wanted to train something from scratch without too much use of transfer learning. And who doesn't want to eventually play chess against a robot arm? Background of this project, chess and computer vision has been done before. It's usually done from the starting position. It just follows the movement of the pieces. Usually an overhead camera's light setup is required. This method isn't accessible to everybody. It's not as readily available. My new method uses an advanced recognition algorithm called Yolo, and it can be used on a normal laptop without any special equipment. The project concept is as follows. I start off just teaching the algorithm to recognize chess pieces. Then we train the algorithm to identify multiple chess pieces, then their board location, and then eventually build a robot arm. We're about 60% through the detecting board location part of the algorithm. What is Yolo? It's an advanced open source algorithm. It's one of the best on the market. It stands for you only look once. It's trained on a neural network written in C that has 75 convolutional layers and 31 other layers, or 106 layers total. It looks like this. Basically what it's doing is it takes the input image and looks at it 3 times at 3 different scales. Instead of running a sliding window through a CNN, Yolo only looks at the image once, then assigns bounding boxes to regions of interest that the CNN has identified as being significant. The results is a series of boxes that we pruned the highest values. So you start off with this picture here, and you notice a dog, a bike, and a car. Each box here is responsible for predicting if an object on a list is inside of it. Then goes to the next image where all those boxes have been drawn. And then we prune those boxes down to the 3 most significant ones in this image. If we chose a board, we might have gotten a tree and a street and other things like that. You'll achieve some impressive results straight out of the box. This is without any additional training by me. It recognizes all these animals, these objects, and this person. So what are we doing? We're going to label everything. How are we going to label everything? Just note that we're going to spell night wrong on purpose, and we're going to label everything white in capital letters, everything black in lowercase letters, just as normal chess notation. But Yolo doesn't come with a way to detect chess pieces, and there isn't much pre-labeled data to use on the internet. So I ended up taking 1,795 images and classifying them individually. You notice I drew a white box around each one of these pieces and classified them where they are on the board, what kind of piece they are, that kind of thing. Then I trained the model on that data, and these are our initial results. You notice it has 12 classes here, one for each piece, and it got 9 of them right away, and it missed 3 of them on the initial training set. And this is what it looks like on the board itself. If you can notice, it's a little bit clustered. It's not really terribly sure about what it's seeing. So we did additional training with more images of the board, and we ended up with this image right here. These images rather right here, where you notice it is identifying pieces on the board, but there are a few false negatives. If you notice, these are objects that it missed that were there, but they didn't recognize them as chess pieces. And there's one incorrect identification here where it said this king is actually a rook. But what about where the pieces are? That's the next part of the algorithm that we're still working on. Yolo data does contain the locations of each of those data boxes, bounding boxes. So what we are working on right now is taking the image itself and transforming it, detecting edges, using augmented reality tags potentially to get the edges of the board like this. And once we have the edges of the board like this, we can find the 4 corners of the board. Once we get the 4 corners of the board, we can find the center points below 1/3 of these pieces that we detected. We can transform the board into a flat board like this, which is an 8x8 grid. Then we can split the grid into 8x8 grid and use a script to run through each row, each one of these boxes, and see if there's something there. and then find the knight here, the king here, the bishop here, the rook here, turn it into FEN, which is a chess notation, and dump it into a board like this. Which Stockfish, our chess engines, can say is an invalid board position because there's no white king on the left as our result. On the right is the actual position, what we should have found, but we're pretty close. Performance review on the whole, the most common issue I'm running into with this project is misdetections. There are a few misidentifications, but they're pretty close to the actual right answer. And I think with additional images, more training time on the model, and alternative perspectives, we can enhance this detection. Are there any questions?